All right, so this project here is for I'm not sure what year, but it's for a Cougar, and it's a customer slash friend. The problem that he's having is no matter what, basically goes to 230 degrees. It just overheats like immediately. Even if it's like cool outside, it still overheats. So the problem is most often than not, the fact is that the fans that they're using to actually pull air through the radiator, even on the freeway, are just inadequate. I think these are like rated at like 7,000 CFM, or not 7,000, 700 CFM, and it's just not enough airflow. And what happens is, if these don't push enough air, even though you're on a freeway and you took the fans off, it probably would stay cool. These end up being a restrictor, right? It's like a fuse, not a fuse, but a resistor. What we're going to do is design a whole new manifold that's further off from the. So what happens is the air has to go up, and then it has to make a right angle turn, and it has to go this way, and then it has to go up. Well, that slows airspeed down. We all know that from fluid dynamics and CFM for the induction systems. Same thing here. Every time that the fluid or air or gas has to make a directional change, it slows down. So it's resistance in the system. So we're going to design a new shroud setup with these, with the new fans, and the fans that we purchased are here. So these are rated at about 1,500 CFM a piece. So one of these is equal to two of those. Now they're a little bit larger, and that therein lies the problem. So these are way beefier. So we did this on a prior project on a Mustang, and it worked really well. So we are going to position these fans here. So the fans are actually going to hang over the amount of real estate that we have. So we're going to build like a manifold that goes underneath, and then so we can capture, and we're gonna increase the distance from the face of the radiator to the fan.
So it has more time to turn.
Yeah, there's more room, more time to turn, and then it should be a huge difference in the performance. So obviously you can see these are much bigger than those, and the armature is a lot larger too as well. So there's a lot more beef on this one.
How much were those?
I think they're like 200 or no, 170 a piece, I think.
Oh, okay, that's not bad.
So yeah, you'll take you step by step through the process. So the first things first is take these off, measure everything, draw it up in CAD, and make a manifold, and start piecing that together. So
nice.
All right. All right. So here's the top and the bottom shroud plates for the 24-inch radiator. So this is the part that's going to go against the radiator, and this is going to be spaced out an inch above this plate here, and there'll be a 1-inch strip around it, and the fans will sit directly on this plate here. So I have my CAD drawn up, and here is the plate, 1/8-inch aluminum. So just a matter now, just pushing the button. got the fans on, got them mocked up, with the top plate cut out, the bottom plate. The next thing left to do is to build the perimeter, basically the box around it, on the outside, table of it, all the way around, and then put nut certs inside the radiator on the flame side, so that way it can be taken out from here, right? So you don't have to, because obviously once it's closed up for good. So, but that's going to allow a ton of flow, more than what it was. So, yeah, so I'll probably take this off. So you got your top plate there, cut out, and then the base here. And what we're gonna do is drill holes through this base plate. We'll put some foam behind there to make up the distance between here and here, and then, or some standoffs. And then this will basically be the manifold portion of it. And then that's it.
Nice. Looks good.
I may even put an extra strip behind it just to space it out. We'll see. We'll see what happens. But that's the basic of it, or the gist of it. So, and this baby's gonna cool. It's gonna be like 120. No.
So you're saying it was overheating to 230?
All the time.
Really?
Yeah. So Richie said he couldn't get down the street without it freaking overheating. So,
Yeah.
So we're gonna fix that. And this setup is basically, it should be.
So is this the radiator that was already in it?
Yeah.
Oh, okay.
Yeah. And this is the nice one that supposedly that he got. So anyway, so this will help remedy that problem.
Nice. What size motor does it have?
I think it's a 400.
Oh, okay.
Either 347 or 400, something like that. So there you go. So the next shot will be basically me welding the perimeters.
Alright.
And I'm going to use this here. I'll use this as the,
Oh, okay.
I will anneal it and then bend it around the perimeter. And if I need more, I'll just make some more on the plasma cover.
Cool.
All right.
Nice.
Alright, that was the second to last weld. So I just need to cut a little notch here for the filler neck, and then, or not the filler neck, but the inlet for the radiator, and then I can start mounting the fans.
See what he's up to.
What's that?
So I'm gonna see what you're up to. You custom made that?
Yeah. So this is the old shroud.
Honey,
Here.
you need a patent that.
So this is a 212-inch fans. Well, it used to be this. So
Yeah.
you can see in contrast. And then you see the height, which was only about a half-inch effective height difference between the radiator face and the shroud.
Wow.
So this is 1 inch. Basically, the spacing from the face of the radiator is 1 inch from the face of the shroud, and this should allow a ton of flow.
What's this going into?
Cougar.
Nice.
That's what I look like a coal miner. I polish everything up,
Yeah.
and then so yeah, everything should be. So there's more real estate. The fans take up more real estate than is available, so then that's why I made these shroud pop
Right.
outs. And
That's nice.
it's cool.
Yeah, very.
So yeah, we'll That's what it looks like. That's what I've been doing.
That's what you've been doing all day?
Yep.